All right, thanks, Zaya. Well, we warned you that would be a high-voltage story, but this next one is too, because earlier this week, we told you about how cracks have started to be reported in some Airbus A380 jumbo jets, which is not good news.
No, that is not good news at all. The A380s are made of a new carbon fiber composite, which is extremely lightweight, and that makes the planes more fuel efficient, but how does it hold up against lightning? We
decided to visit a lab in Cardiff, Wales, that's using super high-powered lightning to test the next generation of airplane materials.
Lightning, one of the most powerful forces in nature.
A real lightning bolt is, say, about 33,000 amps.
Philip Bleishauer's homemade lightning is 3 times as powerful.
Lighting circuits might draw, say, 1 amp, and a kettle might use 10. But here we've got 100,000, which is a lot bigger. We make lightning to test aircraft parts. Now that's really important, because aircraft get hit by lightning about once per year.
Normally, that's not a problem.
Things with very good conductivity don't really blow up at all. So, aluminium with no paint on top, nothing's going to happen there.
To demonstrate that, Philip bolts a piece of a plane to his blasting table.
This test is going to be to aluminium. It's what aircraft are made of most of the time. We're putting in a very fine fuse wire because we're not interested in it conducting. We just want it to bridge the gap between the electrode and the plate. Creating lightning is pretty easy. We turn the chargers on, and we put the energy into the capacitors. Once they're full, we get to press the fire button. That sends compressed air down to the switch, which rams one piece of copper towards another. And then when it's close enough, it sparks over.
Philip wants a detailed record of what happens when his lightning hits the metal.
The camera we've been using is a high-speed camera. We've been running it at about 30,000 frames a second, which seems optimum.
With a very small aperture setting.
It's insanely bright. It's about 200 million watts just in the arc that we're looking at. And that's intense.
It has to be positioned perfectly.
Okay, I'm taking it up, Chris.
Out in the lab itself, it sits inside a metal box to protect it from all the RF.
Is it high enough, Chris?
And it's got a piece of perspex in front of it to stop any debris hitting his lens and damaging it.
Nearly there. Carry on.
We connect to it via fiber optics and control it from a laptop in our control room.
Okay, that's fine, Phil.
Then the entire lab is cleared and locked down.
Right, the camera's ready. If you want to start the charging.
Charger on.
Now the 20-second wait for it to charge.
Charger off. Ready to fire?
Fire. Okay, we got it.
On video, everything looks good.
Oh, with this captured really nicely, we can really see exactly where the arc was, and we can see it reflecting in the aluminium surface. If that was the wing of an airplane, it would be absolutely fine.
Even with Philip's super lightning, there's only a tiny mark on the aluminum.
Slight blemish on the surface. Superficial, really.
That's great news for the planes in the air today, but Philip has his eye on the future, when planes will be made of carbon fiber.
Aircraft companies want to use carbon fiber because it's a lot lighter and it resists fatigue so much better than aluminium.
But there's a downside.
It isn't so good against lightning. It's about 500 times more resistive, which means it's 500 times harder to get electricity to go through it. And it thus gets 500 times hotter when you hit it with lightning. If you just had untreated carbon fiber with no means of conducting the current around it, it's almost certainly going to have a hole blown in it. And that's not good.
Building a plane out of untreated carbon fiber would be suicide. So Philip tests carbon fiber that's coated with a thin layer of conductive metal.
Okay, ready?
Fire. I think we got it.
All right, Phil, this looks good. Want to come and have a look?
Yeah, that's just the top few plies will have evaporated some of the epoxy. But let's take it out and have a look at the other side. There you go, Chris. Absolutely nothing. Did you hit here? No. So, all's good. This piece of aircraft skin is absolutely fine for use in flight.
The layer of conductive mesh did its job.
And you can see that it's not good enough to carry all the current in one small area, but it doesn't have to be. Once it's gone around about this big, the current going out through it isn't enough to melt it, even though we've got 100,000 amps going through this.
Philip will continue to test a variety of coatings, different metals, and different thicknesses, making sure the planes of the future can survive the biggest blast Mother Nature can dish out. Now, we've got something else to show you from the guys in the lab you just saw. And this is going to show you two things. One, scientists are fun people.
Contrary to popular belief. And two, that the Mythbuster methods are alive and well. Check it out.
Now, here at the Lightning Lab, we do a lot of important scientific work and keep aircraft flying, but we also like to have a bit of fun. So here's a slinky, and we're going to see what happens when we strike this with lightning. Okay, I think that might stay there.
Okay.
Okay, he's got it. Let's do this.
Do it.
Okay. 3, 2, 1, fire. That is spectacular. You want this footage? That is awesome. Wow, just look what it did to that. I don't want to touch it. That's going to be still hot. No, that'd be stupid.
Frosty's gonna get it.
3, 2, 1, fire.
Uh-oh. Frosty got it.
Dan and Zaya, we're sorry you couldn't make it down to Cardiff today, but we're going to give you a taste of what we do here at the Lightning Lab.
Okay, ready?
Fire. This is the best silly thing I've blown up yet.
These guys are strange.
Yeah, that'll take the wobble out of your bobble, if nothing
Certainly
else.
would. Look at that. Zaya's lost her elbows.
She lost her elbows. I lost a foot and an arm.
You've never looked so good, I gotta say.
Oh, you're very kind. Thank you for saying that. It's all for science.
All for science.
Okay, who says you can't have fun at CES? Zaya checks out the Z-Board in Las Vegas, a weight-sensing electric skateboard